So this is the fourth one. It says show that n factorial is greater than 2 raised to the power n for all positive integers n greater than or equals to 4. So solution to this, following the same rule, since n is greater than or equals to 4, then we start for n equals to 4. So if n is equal to 4, let's check if n factorial is actually greater than 2 raised to the power 4. So this implies that 4 factorial should be what? Should be 24, and that is surely greater than 16. So this is true for n equals to 4. So now, induction hypothesis, n should be k. We take n, we make n k. So when n is k, then it implies that k factorial is greater than 2 raised to the power k for k greater than or equals to 4, according to this. So now, for the last and the most important one, we make n equals to k plus 1. We don't just make it, we then prove it that yes, this is actually still correct and it still holds when n is equals to k plus 1. So if n is equals to k plus 1, that implies that k plus 1 factorial is greater than 2 raised to the power k plus 1. Yes, we are to prove that left hand side is greater than right hand side. So now bringing down the left hand side, we know that k factorial, k plus 1 factorial, that can be written as k plus 1 times k factorial, right? We all know that. So we also know that from this induction hypothesis, we also know that, I should write it here, we also know that k factorial was greater than 2 raised to the power k. So multiplying both sides by k plus 1, just so it can look similar with this. So multiplying both sides by k plus 1, we have k plus 1 times k factorial right here is greater than 2 raised to the power k times k plus 1. So yes, we can write this as k plus 1 k factorial should be greater than 2 raised to the power k times k plus 1. So right, this is true. So now we can expand this, and actually we can go back and write this as this, since this can be written as k plus 1 factorial. So now we can expand this and we say this is 2 raised to the power k times k plus 2 raised to the power k. So now we all know that k is greater than or equals to 4. So now if we change this to be 4, then this whole expression should be greater than or equals to 2 raised to the power k times 4 plus 2 raised to the power k. We have that k plus 1 factorial is greater than 2 raised to the power k times 4 plus 2 raised to the power k is what? That is 5 times 2 raised to the power k. Why? Because if this was a and this was a, 4a plus a is 5a. So this is 5 times 2 raised to the power k. So now we can clearly define that since we are to prove that this is greater than this, and I know I can rewrite this as 2 raised to the power k times 2. Yes, because we can split it according to indices. So I can write this as this. I can clearly define that 5 times 2 raised to the power k, sorry for that, 5 times 2 raised to the power k is greater than 2 raised to the power k times 2. Obviously greater than it. 5 of this is greater than 2 of this, of course. So I can deduce from that that k plus 1 factorial is greater than this, and this is greater than this. So therefore this is greater than this. So this is greater than 2 raised to the power k times 2. And this I can write as k, I can write that as 2 raised to the power k plus 1. So it is proven that k plus 1 factorial is greater than 2 raised to the power k plus 1. So I hope this helps someone. Thank you for watching.